everyone. Thank you for attending this webinar by Randy Oliver. My name is Pat Bono, president of New York Bee Wellness, which is an independent educational grassroots charitable 501c3 organization. Its mission is to educate small-scale sideliner beginning beekeepers. We do have a YouTube site with past in-person and online presentations, including many by Randy. New York Bee Wellness sends out newsletters several times a year, and it also conducts statewide surveys twice a year for non-migratory beekeepers in New York State. Okay, Randy, you're on. Thank you so much for being here.
I'll give you another link in a minute to put up there also. So hello, everybody. Now, I spoke about oxalic acid and some other miticides not too long ago. So I cut down a brief review of that, and then we'll move on to my more recent research here on oxalic acid. So just to start off, oxalic acid, very natural, safe product to use as a miticide. This is my grandson doing what all kids who grew up in California do, is you suck on, we call it the sour grass. It's not a grass. It's Buttercup oxalis, an introduced weed, but it's a beautiful yellow flower. And when you suck on the stems, they taste like lemonade. And that's a mixture of oxalic acid and sugar in water. So essentially the same thing that you dribble on the bees. And we all grow up sucking on it because it tastes good. So anyway, very safe product. Now there's different methods of applying it to colonies. It's been used in Europe for a long time. We've used it in our operation for over 20 years with great success. So the most common one is the dribble method, 5 milliliters applied per seam of bees. And that's still questionable. There's some research out of Estonia suggesting a greater number of milliliters per bee at a lower dosage, lower concentration can work. I've done a little bit of research on that. The limitations are, it's very efficacious if there's no brood in the colony, a very poor efficacy if there is brood in the colony. The other thing is, I'll show you in just 1 second, is that you don't want to be repeating it. But first, if you're going to mix it, you can just Google oxalic acid treatment table, and up will come this page from my website. And it'll give you the different formulas that you can use. We generally use the EPA approved one, is this weak one right here. In warm climates, where you're going to have a very short winter, the hot solution works, or for cleanup. If the bees are, say you're going to be rearing brood and they're creating a bunch of young bees, then its hot solution can work fine. Other than that, it can set the colony back a little bit. But in our operation, we generally use the medium right here. So we did a test last summer of seeing what would happen if we dribbled it 4 times at 4-day intervals to extend the application when the colonies did have brood. What we found, and we tried 3 different formula ratios of it, and the control group right here. And on all these graphs, the starting mite count will be on the blue column, and the ending mite count will be on the red column. So what we want to see is a lot more blue than red. And as you can see on this is the mites per half cup of bees right here. We did not get very good efficacy, despite 4 treatments at 4-day intervals. But the interesting thing was, we also measured frames of bees, colony strength over that time. And notice that these colonies did not grow much. The blue column and the red column are very, very close. But look at the control group. They got no oxalic acid. They all grew. Every one of them grew, whereas these didn't. So apparently there is an adverse effect from doing repeated dribbles of oxalic acid during the summer, which is going to lead us to other ways of applying it to get efficacy during the summer. If you are going to do the dribble, you can use a syringe, works very well. Another thing that works, I should take a picture of it, is just one of those plastic ketchup applicators with a plastic bottle with a little pointy spout. That works for like a couple of colonies. If you're doing many colonies, we use a garden sprayer set to a gentle stream, mostly full of air, so the pressure does not change as you're spraying it. And then we get a graduated cylinder and we calibrate so we can eyeball so that we put out 5 milliliters per second. So when you're putting it on, you just go chimpanzee 1, chimpanzee 2, chimpanzee 3, chimpanzee 4, like that. You don't have to, you don't even let the trigger off. You just go up and down in between the seams. It has to get on the bees, not on the wood. And we use this for a early winter cleanup as soon as the colonies go broodless. And it can be down almost to freezing temperature. And we split the boxes open, make sure that we dribble the bees in the top box. On the top box, we'll shoot above the cluster, gravity-wise above, so that it'll dribble down through the bees. And down here, we just dribble across the top. If most of the cluster is in the upper box, we remove the cover and dribble from the very top also. But you need to disperse it on the bees, and you'll see why in a few minutes. Now, if you're going to use it during the summer, and this is being used widely in Europe now as the synthetic miticides fail because they've been using them longer than us, they create induced brood breaks by caging the queen they usually do it for a long time. 2 weeks is all you need to cage a queen for to make an induced brood break. The thing is, the colonies really don't like having their queens caged like this. And sometimes they will not accept the queen after you release her because she hasn't been laying eggs. Another way you can do it is with using these division boards. We use these. These are homemade, and you cut a queen excluder in half, cut a piece of plywood out, so it goes all the way to the lid and all the way to the bottom board, and then you lay that half of a queen excluder on here, trace it out with pencil, and cut that rectangle out, and just staple it in place. And you make 2 of these, so you can put one right here and one right here, and put a frame of drawn comb in the middle, and put your queen on there, and the queen is trapped on that frame, and just lay on that frame. So here's the and we use this for queen rearing, and we keep the queen on that for a day or 2 or 3, and then when you pull that frame out, you have all even age larvae all in the same frame for grafting. So we use these a lot, but you can only have to confine the queen for 2 weeks on this frame. And then on day 21, you pull that frame out and freeze it or deal with the mites in that one frame, because there will not be any brood in any of the other frames. And then you can hit them with an oxalic acid dribble at that point and clean out almost all the mites in the colony. So you release the queen, you confine the queen on day 1, then day 14, you release the queen. So if you do it on a Saturday, confine the queen, 2 Saturdays later, release the queen into the colony, let her just lay on the other frames, because it takes 8 days before any brood gets capped over. So you have 7 days that you can apply that oxalic acid. So on day 21, you go ahead and remove that varroa trap frame and dribble the colony with oxalic acid at that point, and you get very good mite control that way. The other option is oxalic acid vaporization, or OAV. It's also inexpensive and relatively quick. But we find we much prefer dribble to vaporization. We find that it's cheaper, quicker, easier to do, and more efficacious. But a lot of beekeepers go for this part right here. Not necessary to open the hive. This is very popular with beekeepers because it's a treatment you can put on without opening the hive. Hey, David, good to see you on there. The question is, how efficacious is it? So here I am. I have tested with the OxyVap 110 extensively, and what I found is it took almost 10 applications during the summer for me to bring the mites down. So I've gotten data sets from beekeepers across the United States and in some countries around the world also, who have counted mice after application, repeated applications, and given me their entire data sets. So I'll be writing about this, but I've analyzed a lot of data sets from beekeepers. Here's an extreme one from Seattle, where this beekeeper was vaporizing at the approved dose of 1 gram per brood chamber at 4-day intervals. Each one of these red triangles is an oxalic acid vaporization at 4-day intervals. Now, if it were efficacious, after a couple of these, you would see it drop down. You wouldn't get any more mite drop coming out. But as you can see, even with repeated at 4-day intervals, it took 1, 2, 3, 4, 5, 6, 7, 8, 9 vaporizations to get it down here. And they laid off for 4 days, or for about 2 weeks there. And then bingo, the mites are coming back up, and he had to hit him another 3 times to bring him back down. What I'm seeing is for most data sets, it takes 7 to 10 vaporizations at that dose in a double deep colony with brood to bring the mites way down. So just don't think that you're doing one vaporization in the summer is going to do anything for mite control. Now, one of the reasons is that this research from Cameron and Jack in Florida found that 1 gram per brood chamber dose is too low. Really, it's going to take between 2 and 4 grams per brood chamber to get efficacy. And you'll see later, I'm going to show you results. I tested it with 3 grams per brood chamber, not for efficacy, but you'll see in a minute. So the thing with what we want is when the colonies have brood, we need to extend the release of oxalic acid, similar to when you buy an apivar strip or what was that first one? The brown strip. We're spacing it. Anyway, the synthetic miticide strips embedded in plastic, they're extended release. They release the dosage over a continued period of time, like 8 weeks for the apivar strips. So some Argentinian beekeepers came up with this great idea. They could do extended release oxalic acid by dissolving it in glycerin. Now, this is not legal anywhere in the United States. I get a pesticide research authorization every year from the state of California. I'm the only beekeeper in California who can legally do this for experimental use. So I want to be very clear. Randy Oliver, does not advocate or encourage the use of this treatment method without a permit. Okay, now I've covered my butt on this. What I'm going to show you now is only my research, just like USDA scientists who do research and then publish it to develop products. I'm just going to show you what my research is. I'm not trying to tell you to go out and use this. What we found is we've tested a bunch of matrices. I'll talk about it later. And what we found is these Swedish sponges work really well. I should change this. It says 2 25-gram sponges. So this is one Swedish sponge, 7.5 by 8 inches, cut in half. So 2 strips of that. And what we found is, notice we get a lot of blue and very little red. This means high efficacy here. We got 90% or better efficacy when we applied these. So very, very happy with this. It takes a while. It takes 60 to 70 days to reach full efficacy. And the question we wondered, well, if you have that dose, you're putting 50 grams of oxalic acid into the hive as opposed to putting 2 grams in with a vaporization or a dribble. So the question was, would that affect the brood? Well, here is one after 60 days with the 2 pads still in here. And you can take a look at this brood, the brood patterns right here, and draw your own conclusions on how it's affecting the brood. Now, what was very interesting to us is we were also working with a researcher, and she is actually just publishing right now the results of this research, and unfortunately found that there was these were done at high elevation, 6,500 foot elevation in the Sierra Nevada, up above me, at these wet meadows. And there was a flower that she was studying to see the interaction between the native bees and the honeybees and the effect of having honeybees upon the seed set on these flowers. And unfortunately for us, she found out the honeybees are detrimental to the seed set of that particular species at that elevation. So this isn't not across the board, but at least for that one species, very clear data that there was a negative impact by having honeybees up there, which is unfortunate for us because we were hoping to use this as an isolated mating yard for our selective breeding program. So there were no other honeybees up here until we bring them in. So there's no feral population, no other beekeepers up there. The interesting thing was, look at the lack of red. These colonies all came back. Now look at the starting mite counts. That's 50 mites in a half cup of bees. Normally that's the kiss of death for a colony. A lot of them up here in that 30, 40, 50 range, okay? Very serious mite levels. And they took them all down to zeros. This is at 77 days afterwards. Just completely eliminated the mites from the hive. The difference, as far as I can tell, was that there were no other bees around, so no neighbors who had mites drifting into these hives. So this is telling me that if you have a bunch of neighbors who are not controlling their mites, then the extended release oxalic acid may not be as efficacious. And I did a bunch of follow-up research on that this year, but unfortunately, there were almost no bee drift in our area. In the 7 yards that we investigated, where historically there's a lot of bee drift, we didn't get it. And mite immigration is a real thing. And you can tell this is some data from 2019 from 6 hives that I kept at my home yard next to my house. And this is your mite drop per time period. So we were checking twice a week. So each of those time periods is about 3.5 days on average. And so this means that you got 15 mites on the sticky board right there. This would have been 24 mites on the sticky board on that hive. Now, we've eliminated the mites with heavy dose of miticides to clean them out. So any mites that you find on the sticky board came from incoming drifting bees. And you can tell that because we got 2 rainstorms and a wind. And notice what happens. When it's raining or windy, your mite drops, your sticky board counts drop almost to 0. All you're getting is a few of the residual ones that had come in a couple of days before and are dropping off. But there's no mites dropping from within that hive. These are incoming mites. And as soon as the rain stops, bingo, you have an uptick in mite immigration coming in. So mite immigration is a very real thing. And if your neighbors aren't controlling their mites, they're going to be hurting your hives. The original formulation out of Argentina was using these chipboard strips. Chipboard is flat cardboard is called technically chipboard. There's all different types of chipboards. So they use research in chipboard, and they have a product, the Aluen Cap. So Aluen is a town in Argentina. CAP is Coordinated Action Project of beekeepers working for the benefit of beekeepers. And they came out with this product, which they now call Aluen Cap. I don't know why they use the same name for the product, but they're looking to register in the US. I was just down speaking in Chile recently, and it is widely used and sold down there. When we first tried this out, making my own duplicates back in 2015, put them in hives, and yeah, they definitely worked. And I told my son, I said, Eric, this is great. Look at these things. They really work well. And he takes a look and he goes, and how many strips did it take per colony? I said, well, it took 8 strips per colony to do it. He goes, let's see, 8 times 1,500 hives. That's a lot of strips for us to put in and take out, Dad. You got to come up with something else that's not so labor intensive. So for the hobby beekeeper, this can work. What we found though is this is actually relatively poor at distributing the oxalic. A sponge laid across the top with half the surface area gives you equal results. You have to almost double the surface area for hung strips as you do for sponges laid across the top bars. That's totally counterintuitive. And like many things with beekeeping, when you've convinced yourself that something makes total absolute sense, and then you actually go out in the field and test it, it's exactly the opposite of what you expected. And all bee researchers are used to that, seeing exactly the opposite of what you've convinced yourself will happen. So we tried it first using the old commercial beekeeper standby, the blue shop towel, which beekeepers have used for off-label treatments for many, many years. And these worked okay, much easier to put than the shop towel, than the strips. But the colonies, depending on huge variation on whether they chew these up or propolize them or remove them or don't touch them. So we needed something that had a more extended release than this. So we moved on to these Swedish sponges and found these work very, very well. They're the gold standard so far. Now I'm not giving up yet. I'll show you here soon. And so we do put on the strips like this, just one near the front, one near the back of the hive, and leave room for a pollen sub patty in the middle, right between the 2 hives. The bees have to walk on the top and the bottom of the strip. You can't do it like this with a cover immediately over it. And then we did run tests to see exactly how much surface area you needed. So we cut the sponges into 4 strips and tested either putting in 1 strip per hive, 2 strips, 3 strips, or 4 strips to see how much surface area was necessary for good efficacy. And for a double deep, it does take the 4 strips, the equivalent of 1 full Swedish sponge, about 55 square inches of surface area to get good efficacy at 2 months. Now, I've tried a number of other things of materials to do it. This one right here is the maximizer pads, which are about a 1/10 the cost of the Swedish sponges. These are about $1 a piece. And the If You Care brand, we do like that because it has no plastic fiber. It's totally biodegradable. After you're done, you put these right in the compost pile, and the critters in the compost pile completely biodegrade these. Here's the maximizer pads, much cheaper. We've tested the lightweight. We haven't tested the heavyweight. And it's on my website. You don't have to email me. It's this model number here, GPC 100S, okay? And we just cut them in half using a paper cutter and prepare these. I've also tested cotton matrices, different ones. We weren't that impressed with the cotton matrices. I've got a couple of new ones on my counter. I've already made them up. They look good, different matrices, and I'll be testing them this year. So we have not given up with this. What I'm showing you is preliminary research. This is not a done thing. I'm not saying we have a method at all. I'm just doing the research, because all my research is supported by donations from beekeepers. I'm giving the beekeepers a shareholders report of my research. So very easy to prepare. Then we put them like in a plastic tub and carry them around, easy to peel off, especially with the 1-to-1 ratio formulation, which I'll talk about here. And we also we like getting these restaurant inserts here, stainless steel restaurant inserts, because they can be heated up. So very easy to make the sponges. We either pour it over the top, or just when they're halfway absorbed, flip the sponges over on edge and let them all soak in. So what we prefer so far is the 1-to-1 formulation. That's 1 gram of oxalic acid to 1 gram of glycerin. That's a supersaturated solution. So you have to heat it up to get the oxalic acid to dissolve. And then once you let it cool, it will crystallize on the outside of the sponge, unless you're in a high humidity area. And then the glycerin, and this is what the glycerin does, it absorbs moisture from the air. Oxalic acid, dry oxalic acid, is harmless. If you're not sweating, you can put oxalic acid crystals all over your skin and you're not going to feel a thing. The moment you sweat or add water, then that allows the acid to dissociate, and then the free hydronium ion, and that's what I'm going to be talking about later. The hydronium ion is the H+ or H3O ion that is positively charged. That's the active thing. The oxalate ion does nothing. That's whether it's oxalic acid or citric acid or lactic acid, it's none of the citrate or the lactate or the oxalate ion is not important. It's simply the H+, the free hydronium ion. Okay, oxalic acid just happens to be a food grade acid that's of the right dissociation constant to use. It's the strongest organic acid. So the glycerin then absorbs moisture from the air. So when you, in our dry climate in California, these crystallize and they are kind of dry to handle. When we put them in the hive, within a couple hours, because the humidity within the hive cluster is higher, they start looking wet. And we want them to look wet. If they're not looking wet, they do not have the efficacy against the mites. Now, the Argentinians use a much higher ratio of glycerin, 1 to 2.5. This does not require any heating at all, but it is sloppier to handle. So if you just let it sit overnight, it will dissolve, and then you can make these. But you get, when you handle them, you get glycerin and acid all over your gloves and your tools and everything else. So we like this ratio right here. But I'm going to show you some data in a minute that I just discovered moments ago. I was talking to Pat that when I'm preparing these PowerPoint presentations, sometimes I go, wow, you know, I didn't notice that in my data, and I just had that aha moment a few minutes ago. So I'm very excited about that. I'll show you what it was. We also like these pads hung over the laid on top. We also sometimes use them hung over the top bars on the frames, but I don't have the research for these as far as how much surface area hung over. So if you're a top bar beekeeper or you have singles, you probably better off hanging them over the bars. Now, here's your other one right here, Pat. Go to my website and click on this, how to use OAE, and copy that link and send that out. You don't have to email me for, if you're a researcher and you want to do this or do experimental use, or in your state, it's currently approved for a very short time, maybe. All the instructions are right here. You don't have to email me for instructions. Now, one thing we have learned while we're doing this, we're feeding pollen sub, you can't let the pad touch the pollen sub. The bees will not eat the acidified pollen sub right there. The other thing that we've done experimenting with is if you have a high mite count and you want to get the mites down quickly, this will not do it. This takes, like I said, 60 to 70 days to get the mites down. So we often will put in a thymol treatment or a formic treatment at exactly the same time. Open the hive once, put in 2 treatments, a very fast-acting thymol or formic to knock the mites back, and then this oxalic acid pad. And we've also tried a little bit with just putting a dribble on and then this on top. So we need much more research on those combination treatments. So it's a wham bam treatment. One's a fast-acting and one is a slow-acting. And also be sure you don't just use one mode of action for mite management. Rotate your treatments. So what we rotate is thymol, oxalic, and formic. We don't use any amitraz, but that could be in this rotation. Otherwise, you just started a breeding program for resistant mites. So make sure you rotate your treatments on the mode of action of the ingredients. Come on, there we go. Now, let's get into the nitty-gritty here. There's a number of questions. One, how safe is it to the bees? I can tell you right now, with the 1-to-1, we don't see any adverse effects. If you put too much in, yes, you can. And with the high glycerin, we've also seen possible adverse effects. But in general, we don't see any adverse effects. Why and how does it affect the mites? Well, we'll talk about that. We're not really completely sure on that. What's the optimal dose? Right now, I will talk about that too. How long does it continue to affect the mites? Well, 60 to 70 days with the extended release, much shorter with the other application methods. Then the big one, are we acidifying our hives? If you put an extended release in there with that 50 grams, do those residues build up in the hive? That's a very valid question. So I'll answer that one for you. And why the differences in efficacy between the various application methods. So let's take a look at all these questions, and that's what I'm going to try to cover in the rest of this presentation. So first, there's different activities that pesticides have, different modes of action. We don't need to go through all of them. I'm going to now show you the ones that are plausible for oxalic acid. So one, acute toxicity. Yes, if a mite steps on oxalic acid crystals, it can be very quickly toxic. If oxalic acid crystals, that's only if it steps on it because it has wet foot pads, there's water. If the dry oxalic acid gets on the outside of the mite's body, that's not toxic to it unless there's glycerin or something involved, or they move it around and it gets moistened somehow. Chronic toxicity is if something is just deleterious if you are exposed to it for a long time. That's a possibility with oxalic acid. Mice don't normally live that long, but that's a possibility. Then there's cumulative toxicity, as there is like with fipronil insecticide, where if you have a non-toxic dose, like they had on the sunflowers over in Europe, and the manufacturer said, oh, what are you beekeepers complaining about? We've tested this. The LD50 is very low. The dose on a sunflower is way below the toxic dose to the bees. And then they found out, paper was published later, some years later, that, wow, the beekeepers were right. A low dose of fipronil, if the bees eat it every day, you get cumulative toxicity, and eventually it does kill the bees. So that's a possibility with oxalic acid. The big thing that, let me skip down here, tissue damage. So if a mite, the impodium, that sticky pad on its foot that allows it to hold on the bees, if that touches oxalic acid crystals, it just burns that tissue. Oxalic acid, it's an acid, it burns the cuticle, And that can cause loss of water from it, or just destroy the cuticles. That's just tissue damage. So the mite, if it can't walk or grip, maybe it falls off the bees. Then there's behavioral disruptors. We'll talk about that. These are substances that could be completely non-toxic, but if it changes the behavior of the pest, so it doesn't mate or doesn't feed right, it can eliminate the pest without any toxicity whatsoever. So what we're going to focus on now mainly is residual action. How long this pesticide, this oxalic acid, is a pesticide in this use. It's a miticide. So some insecticides have very short residual action. The pyrethroids, synthetic pyrethroids, like on mosquito spray or fly spray, they have immediate knockdown, but very short residual reaction. They degrade very quickly. They don't leave long residues. The organochlorines, such as chloridane, that are now phased out, had very long residual action, up to 50 years residual action. For termites, if you treat a piece of wood with chloridane, you had nothing to worry about for at least 28 years and probably up to 50 years. So it was very popular for treating wood in contact with soil. So this residual action can vary greatly. So the big question we're gonna look at now is how long is the residual action of oxalic acid on the bees' bodies after we apply different application methods. And this is what the interesting thing is. Despite the fact that Europeans and North Americans have used oxalic acid for over 3 decades against varroa, we're completely blind as to how it's distributed within the hive and how it persists in the hive. Then the data I'm going to show you will be the first data that's going to be published when I publish this. That's going to show you I found out. This is there's 3 approved methods, EPA approved on the label of it: the dribble application, the spray application, or the vapor application. So the question is, what's the theoretical dose that each bee in the hive is receiving? Now that's theoretical. Obviously, they're not going to receive the same dose, and some may go on the woodware or the combs. So for the dribble application, they tell you how many frames of bees to apply it to and how much, so you just divide the dose by the number of bees expected on there. And it works out with the dribble application a little over 100 micrograms. Now, a microgram is 1/1,000,000th of a gram, a very small amount. So about 100 micrograms per bee to kill is this dose. Spray application works out to 105, again, about 100 micrograms per bee. Vapor application works out to be about 50 micrograms per bee. But as we've already seen, that's only a half or a third of what we need for really good efficacy. So again, we're around that 100 micrograms per bee level. So keep this in mind. The EPA approved doses are about 100 micrograms per bee for efficacy. So that's just a nice round figure for you to keep in mind. Let's go back to the slideshow. So how big a dose of oxalic acid actually shows up on the bee's body? That was 100 micrograms of the theoretical dose. What's the actual dose? And second, how long does that dose stay there? So one way to do this is by acid-base titration, commonly used in chemical labs. Maybe you did it in high school chemistry, where you have an analyte. This is an unknown acidity of this solution. And I make this by taking distilled water and dropping a bee with oxalic acid on its body into this, and the oxalic immediately dissolves. So now you create a slightly acidic solution. And then you put in an indicator that changes its color as if there's acid in that solution. Now I started off using phenolphthalein, which is the pink indicator you probably used in high school. I found out that phenolphthalein is a great indicator, very clean endpoint. It goes from clear to pink at a very sharp endpoint. But at the pH that it changes every 15 seconds when you're dealing with the micrograms from the carbon dioxide dissolving out of the air into the distilled water and forming carbonic acid. So for me to titrate down to the microgram, I could not use that because it kept changing on me. So I have a good friend who's a chemist. He suggested I use some different indicators, and I did, and I found one that I like a lot. And so what you do then is once you have this color change, then you mix up a calibrated solution of sodium hydroxide. That's household lye, but I use reagent grade. And you drip it in drop by drop, and you measure the drops or the milliliters. And when you change the color of this back to the original, then you know that you can calculate exactly how many micrograms of oxalic acid are were on that bee. So here's what the method that I have developed, and I'm going to publish this. Maybe it'll be a standard method for bee research. Okay, so we make up all of our solutions, all calibrated carefully, and we the pH. This would be for straight distilled water. If it has carbon dioxide in it, it'd be more greenish. And what we do is we let it get carbon dioxide. So we like that bluish green color a lot. But this one would be with fresh distilled water. We drop a bee in, notice the color change. The more acid on the bee's body, the more it'll go towards orange. So a well-acidified bee, 100 micrograms on a bee will change it to an orange color. So this does not have very much here. Now we're going to drip in the a titrant drop by drop, counting the number of drops until it changes back to the blue color. And at that point, we know by how many drops we put in there exactly what the microgram equivalents. We're not actually measuring oxalic acid, but based upon the acidity, the figures I'm going to give you are for oxalic acid equivalents to reach that amount of acidity. Here's an example. So I made up the 6 test tubes, all identical. They all looked exactly like this color. This is our reference solution right here. Okay, and then I took oxalic acid. I made up a solution that would hold 100 micrograms or 10 micrograms per drop. And I put 10 drops in here. So I knew there was 100 micrograms of oxalic acid in here. So this would be 1 full bee dose, changed it to this color, okay? Then I started taking my titrant, which was calibrated to be 100 or 10 micrograms per drop. So theoretically, it should take 10 drops to change this back to the starting color. So I dropped it up, and at 9 drops, this is what it looks like right here. You put the 10th drop in, bingo, you're right exactly back to the starting color. You put 11 drops in, and now you've gone too blue. So we often go for the overshoot. If we're not sure, we go for the extra drop in there, and if it goes blue, we go, oh, okay, back to subtract 1 drop, and that's what the actual rate was. So extremely accurate, and we can titrate down to the single microgram, 1/1,000,000th of a gram, and it takes about 5 to 15 seconds maximum per bee to do this. Now, I developed this technique partially back in 2018, and I was really excited about it. And I had all these bees and the titration stuff out on my bench, and I have visitors here regularly, and I would be very excited to go in and say, okay, you want to see how it works? Well, I know these bees right here, I titrated them just a few days ago, and they were right at 60 micrograms or 70 micrograms, whatever it was. And I go to do a demonstration, and they'd read 5 micrograms or 10 micrograms. I go, what the heck? They've just been sitting here. I haven't touched them. Why would they not be acidic anymore? And that just frustrated me since 2018. I did all kinds of experiments and couldn't figure it out. I did experiments with insect chitin, with shrimp chitin. That chitin is the cuticular substance that bees have for their skin. So this spring in 2022, I said, okay, I got a new lab assistant, and I said, her name is Rose, and I said, Rose, this is your mission. Okay, Rose was ex-Navy. Okay, so I said, Rose, you have a mission now. We are gonna get this figured out and develop this titration method. So we spent a tremendous amount of time this summer doing this to answer how rapidly oxalic acid degrades on a bee first, and then move on from there. So we took bees from a oxalic-free colony. Any bee we've ever taken from an untreated colony never changes any color at all. There's no strong acidity on their body at all. We froze them in the freezer to kill them, and then we put them in a screen cup, and then dipped them into a calibrated oxalic acid solution or oxalic acid and glycerin or oxalic acid and sugar. We also took those solutions and put them onto plastic cover slips, so there's no organic matter. And then we put the bees we let them just drain off and dry and kept them either at room temperature or put them in the freezer to see if freezing would retard the degradation of the oxalic acid. We also vaporized colonies and got the bees out. So here's a bee this would be about a dose of about a 60 microgram dose on this bee. You can see the little white flecks, crystals of oxalic acid on the hairs. If I zoom in, this is what it looks like. So here's a bee at about a 60 microgram dose with these little crystals of oxalic acid. And here's the results. So this is the how many drops we needed to titrate it back at the 10 microgram drops. Here is hours, half an hour, 1 hour, 2 hours, up to 12 hours, then 1 day, 2 days, 3 days, up to 12 days. On the cover slip, oxalic acid and water, there's no change. It's inert. There's no degradation at all. Every other one, you can see very quickly, degrades. As soon as you put oxalic acid, add sugar, add glycerin, or put it on a bee's body, it degrades fast. And even if you freeze it right here, this color right here, in the freezer, it degrades almost as fast as it does at room temperature. You vaporize it. So here's red is vaporization very quickly. So we started out here at 10. So at 2 days, you're down to 5 on those bees. Now, there's no grooming involved at all. Okay, in the hive, it degrades, it's mixed, even disappears even faster because they groom it off. But these are dead bees sitting at room temperature, dry, and you still degrades by 6 days. You got almost no active oxalic acid, no acidity left there. And then add it to glycerin here, or add it to sugar, the green one, it degrades even faster than if it's on a bee. And so it does not last very long, have much acidity. Now, what happens if you put it on live bees? So we shifted here and used a fluorescent tracer that glows under black light. And the advantage of this is this isn't looking at degradation. This is looking at whether the bees actually physically remove it, because the tracer does not degrade chemically, it stays active. So this is a colony an hour after we dribbled it with an oxalic acid and sugar syrup with the tracer added to it. And if you look at these bees, you see these glowing. Now this is out in the field with a opened up black plastic garbage bag over our heads. We lay the frame on the ground in the leaves here and have a ultraviolet flashlight. And one of us is taking a picture with our cell phone camera, and the other one's holding the flashlight and keeping the plastic over our heads. So a lot of fun doing that. But look at these little tiny specks. There's little glowing green speck, little glowing green speck. These are specks in the combs here. Little speck on the bee's body, two little specks on that bee, few specks on that bee, 2 more specks right there. That's what it looks like an hour afterwards. It's not evenly distributed on the bees at all. So then I built a dark box, a plywood box I could drop a frame into with a black light inside it, and then put my cell phone up to a hole we drilled in the side and look more carefully. And again, an hour after an oxalic acid and glycerin dribble this time, a couple of bees had a lot on their bodies. Most had little tiny itty bitty specks on their bodies. You can see all these little specks of glowing green. So take home right now, when you dribble, or even when you vaporize is a little more even distribution, but dribbling is very uneven distribution. Now, that doesn't mean anything bad. I'm just saying that's the fact. So we learned this. Now, what we are curious about is, where does it go? Again, the fluorescent tracer does not degrade, but it wasn't there anymore. So I mix it up, a solution, and I brush the bees off a comb, and I painted the comb with it like this. And you can see the glow right here, very, very intense glow. What we found is after a day, that's all you see, a few little spots left. And by 2 days, you don't see virtually any glow whatsoever on there. Now, there's no degradation. That means this has been physically removed from the hive, okay? And we did see the little specks on the bees also, but that's the last you see after a day. By 2 days, you don't see almost no glow at all. So what's the plausible explanation? Pat, where would it go? Okay, well, Pat's not going to unmute
I
herself.
don't know.
I
Sorry.
don't blame her. Okay, so where does it go? Well, maybe the bees eat it. They groom it up, they could eat it. So we took samples of bees after an hour and after a few hours, after a day, to see if they had consumed it. We crushed them, put them under black light. So you can see the outline of a crushed bee. Here's the crushed guts right around it. And these are untreated bees. And you can see this is what their guts look like. These are treated bees, no glow in the guts at all. We did 150 bees. We found a very few little specks on the outsides of their bodies, but nothing in their guts. So they apparently don't eat it. We have to do more experimentation to figure out where the heck the solution disappears to. Okay, now that we had that background research done, we're ready to move on to serious research. I hope you're all following me. So we went out to a hive, or a couple of hives, that had extended release sponges in them for 73 days, May through July. So this is hot, dry weather in the summertime, July, after 73 days in the hive. We were curious, well, let's answer that question. Does it build up in the hive or not? So set up some test tubes. Notice they all start out the same color. Then we dropped 3 bees into each test tube just to get an average here. Now, first, we also took bees from a hive immediately adjacent to that hive to see what would happen the bees will climb out in hot weather. Dropping into the water does not hurt them at all. So these climbed out, but all these test tubes, this is the reference tube, and these 4 or 5 all had 3 bees put in. Notice no color change. So no acidity in the hive next to it that had not been treated. The treated hive, definite color change. There's our reference tube right there. When I titrated these out, they had between 2 and 3 micrograms equivalent. Very little compared to that 100 microgram dose that we know kills, that is the approved dose, 2 to 3 micrograms in there. So no, it does not build up in the hive. It has this very low residue there. So that was very interesting to us. So now we are curious, well, what happens to various application methods? That was at 73 days. Let's do a study and let's track it for 2 months, for 60 days. First thing you might want to know, for a visual, how much oxalic acid is a microgram? What's it look like? So I scooped up some fine oxalic acid crystals. There's the tip of a chopstick there. I took that little speck right there and dropped it into water and changed it yellow, not quite orange, so less than 100 micrograms. And when I titrated, 65 micrograms. So that's about the strongest dose we usually find on a bee right after an oxalic acid dribble. So that's your visual right there. We're talking about that much on a bee. Now that's 65 micrograms. That 2 to 3 microgram dose was 1/20th of that little tiny speck right there. Very small amount on a bee. Okay, time to get serious. We set up 16 hives and we applied 15. This is right next to my house, so we could do it every day. We did a dribble treatment at very strong 3 grams per brood chamber, so 6 grams total into that hive. We did 3 different kinds of dribble right here, all at the hot dribble solution, but different solvents in them, either sugar, glycerin, or propylene glycol. There's 7 different sponge applications, also with citric acid and with sodium bisulfite, which is a food grade acid also. 1 sponge with no glycerin. We did the chipboard New Zealand strips, 3 of those at different ratios of oxalic acid to glycerin. And then also did the shop towels with the 1-to-1. Then each of these hives was marked on the top. So I took the same frame out of each hive. Every day we did this, or every hour for the first day, would pick up 5 bees from into a test tube, 2 batches from this side and 1 batch of 5 from the other side, always going to a center frame in the upper brood chamber. So we didn't change where we took the bees from. So we had consistent results. So there's 5 bees in there. So this would be, we can calculate the average acidity per bee this way. After doing hundreds and hundreds of these, now we've shifted to doing single bees because it's more informative, but this works just fine for the average right here. And we always keep one reference tube. Here's my assistant Rose. And I had set up a chair with a built-in bench I welded on there for her to do it in the field because it degrades very, very fast. So she could sit right next to the hive and I could hand her those samples. And as I'm collecting those bees, she could be titrating them. Then by August, it got so damn hot that we had a trailer right there, so with a swamp cooler in it. So I set up another bench for her inside so she'd be cooler. And I worked out in the heat and would bring the bees into her. And so here she is. We had fluorescent lighting behind, so very consistent lighting, so she could titrate away inside. And we collected, this is one data page here. We collected lots of data. We did a ton of titrations over time, over 60 days. So here's our 60 days right here. There's all of our treatments. You don't have to, we're going to go into more detail in a minute. We did reapply the dribbles and the vaporization right here, but we vaporized at only half as much dose. And that red line right there is the vaporization. And yeah, we had about half as much acid on the bee. So this is your average oxalic acid equivalent per bee. Remember, the 100 would be your theoretical dose. This is only 30 micrograms here. We didn't get, you're not seeing much in the way of hundreds when you look at averages. And then we reapplied the New Zealand chipboard strips right here. We are now, I'm going to unblind you, and we're going to take a look inside these hives and see what happened. So we'll break it down by application method. Look at, so we did either a 1.5 or 3 grams brood chamber vaporization. And a few of these bees did get hit hard, but initially, within a few minutes, most of them have about 20 micrograms on their body. Surprisingly little, much less than the theoretical what you would expect. We did the 3 dribbles also. 7 different sponge applications. So this is just for the vapor and the dribbles alone. So I'm breaking them out. So the vapor, the high dose vapor, that's this red line right here. And then we reapplied it at the low dose there. But the dribbles actually were higher consistently than the vaporization right there. But all of them by a month were down below 5 micrograms per bee. Okay, now for our sponge applications. So here's all our different sponge applications. And because we had a bump up here after rain, I did put in 2 rainfall events here so you could see here, but didn't seem to correlate with anything. So citric acid, I did a citric acid sponge. That had a really big spike, but then it went down quite a bit. Same with the sodium bisulfate, another good one. So these are both other food grade that are promising that we might want to experiment with other than oxalic acid. This one is used in many foods right here, the sodium bisulfite, and also citric acid used in many foods also. Here's an interesting one. This one was no glycerin, just the oxalic acid at all on a sponge. But look at this, it kept almost the same residue level up to that, you had 5, they're back here. So this was so interesting that about this point in time, I go, that's surprising, it's staying up there. And I made those, put them on a couple of hives and then checked the mite counts. And it didn't have any effect on the mites, apparently. I did sticky board too, did not change the sticky board drop. So something about having the glycerin is important. And we'll return to that in a few minutes, okay? So we definitely need to further investigate these ratios. What was interesting here, so this is a sponge with the 1-to-1 ratio, and the dark red is sponge with the 1-to-2 ratio, 2 parts of glycerin. So, and this is what I discovered, I noticed, Pat, when I was putting this up. Look how low the 1-to-1 ratio tends to be down here. That's the one that we've been using in our last few years. But look at the 1-to-2 ratio, the high glycerin one. It actually tracks higher than the 1-to-1 all the way along. So although we like the handling characteristics of the 1-to-1, the 1-to-2 more glycerin may be better for mite control. So I need to investigate that further. And here's the Swedish strips. I got them direct from, not Swedish, New Zealand, manufactured in New Zealand. I got a bunch of them to test out. So these are widely used in New Zealand. You have to put 3 in per brood chamber and replace them after a month. So six in there and then back again. So in the same treatment, as opposed to just a one-shot putting in a single sponge, you put 6, you're going to put 12 of these in and take them out over that same period of time. So a lot more labor intensive. So we take a look at these here. Now, I also did the 1-to-1 and the 1-to-2.5, the high glycerin one here. So the gray is the 1-to-1 that we use. So here's our gray line here, and here's the 1-to-2.5. So we had just the kind of the opposite here. The 1-to-1 was higher with the strips on the bees for much of it, and the high glycerin was lower, except for this odd spike at the end. So obviously we got to do some more experimentation with those two ratios. The reason, again, being EPA doesn't like the thought of beekeepers having to heat it up at home. So we may be better off just saying, well, let's just go for the unheated one with the higher glycerin content. So now that you've been unblinded, we're really talking less than 5 micrograms per bee, and it's still working against the mites with the extended release. So why is that? And it doesn't work. You're not getting much mite control with the, after a few days, you have very little control with the, let's go back up here. So take a look at this graph right here. All of them still have residues here, but we know that the with the vaporization and dribble, after 3 or 4 days, you have almost no effect on the mite. So let's go down to vaporization and dribble here. Okay, so we know there's almost no effect on the mites after this first spike. So just having these low residues here, they're not effective. You need to have these plus the glycerin from the extended release to get that extended effect. And that's what I'm really curious about. We'll get to that here in a second. So let's go down. Why does it work with those little residues? So again, here's a reference tube. Here's untreated bees, no color change. This is an hour after an oxalic acid dribble. Look at the difference from bee to bee of the amount of acidity. This one got a big dose. This is over 100 micrograms. I can tell you by the color, whereas these are maybe like 3 micrograms or so. After a while, we can take a glance here. We can tell you how many micrograms, very close just by looking at the color. So the question is, how much oxalic acid on a bee's body does it actually take to kill a mite? And I found this great paper. There's been 2 researchers in Italy that have been working with oxalic acid and Thiamol for many years, Norberto Milani and other guys named Nazi. Excellent, excellent research, great scientists over there. In 2001, Milani published this paper. He took a powder spray tower, made little glass dishes, and sprayed them with solutions of oxalic acid and water or oxalic acid and glycerin, let them evaporate, and then weighed them and could tell you exactly what the density was, micrograms per centimeter squared. So this is the first thing I have, only data I've found of surface density of oxalic acid. And then he looked at, he put mites on them, let them walk around for an hour, removed them, put them on live pupae, and then checked them for mortality after 24 and 48 hours. So here's the 48-hour dose mortality curve. I'm so lucky to have found this, okay, that he did that. So that's 100% mortality right there. So we're talking up like 97% mortality. So if a mite walks at 10 micrograms per centimeter squared for an hour, it's going to die within 48 hours. And this is a logarithmic scale, but it's only 1 microgram per centimeter squared. You get little less than 50% kill at 48 hours. So now what we need to do is figure out, well, how many centimeters squared is the surface area of a bee's body? Okay, because I'm dropping 1 bee in. And luckily I found a paper that had used computerized tomography and calculated the surface area, including both sides of the wings of a bee's body. And it's about 3¼ centimeters squared. So now I can do the calculation. So this 10 microgram, which will kill most, is about a 32 microgram dose. So when we see those bees that have a 30 microgram dose on their body, we'd expect a mite walking on that individual bee to die within 48 hours. If we have a 3 to 4 microgram dose, which we see the extended release, we can expect a bee that walks over the average bee to about 45% of those bees, we would expect to die within 48 hours. So maybe this extended low dosage is what's happening in those hives. So, but that's average. So the question is, well, how much do the mites move from one bee to another? Because if they get on a bee with none, they're not going to get killed. If they get on one of those bees that titrate really high, then they will get a lethal dose. Oh, I can't remember his name. Just published a paper that showed that mites do move around. Some move around fairly rapidly from bee to bee, and some don't at all. So there is transfer around from bee to bee. So now I wanted to look at individual bee acidities following vaporizations or dribbles. So right here, this bee, I did titrate it here. It titrated to 1,100, over 1,000 micrograms. Well, that's a little bit high because that bee was dead very quickly, okay? But you can get some bees with very high doses after vaporization. So what I did here, I vaporized in warm weather and in cold weather and tracked it. So this is your hours post-application. The little orange squares are the summertime, and the black points are for 10 individual bees. So if they all had different amounts, you'd have 10 dots right there, but many of them overlapped. Then I put in that 30 microgram level where we'd expect most of the mice to die, and the 3 microgram level where maybe a little less than half would die if they were on that bee. And notice with this is the approved dose, 2 grams per hive. And what you can see right here is we did have a fair amount of them. By the time you are at 4 hours, most of them most of the bees are way below that very low dose. So you're not going to be killing many mites. You do have some up in this higher range up to the first day. So that's why after an oxalic acid vaporization, you're going to see a mite drop your first day, but then it drops off very quickly. Now, this is for the 6 gram dose per hive, so 3 times the approved dose. And now we get bees. Here's one titrated at 130. This one titrated about 98. So you get some really high bees and a bunch of these up here that we didn't have. So some higher dose bees and a lot of them up in this range for a full day. Okay, both summer and winter cluster. So this is showing why you have that high mite drop your first 24 hours after a vaporization, and probably better efficacy at that 3 gram per brood chamber dose. Are you all getting this? We are unblinded now. We can understand why these different oxalic acid treatments work. This is like, insight into the hive. We've just been totally blind to this. This is very exciting to understand. How about the dribbles? So 2 hives got exactly the same dribble, just to look at hive to hive variation. And again, 10 bees, so there's 10 different dots right here. Summertime averages here and individual bees here. This hive, you had a few bees up here, but now you're talking, instead of by 24 hours being gone, you're out to 4 days up in this here. So dribble has a more extended acidity in the hive. And this hive had a higher level than this one. So there's a hive to hive variation with the same exact dribble per frame of bees. And again, stays up here for much longer. When we go back to those, to here, this is 24 hours. After 24 hours with the vaporization, it pretty much disappears. With the dribble, it extends out to more like 48 hours. You get about 2 days worth on there. So the dribble, again, confirms what we've seen in the field. The dribble gets better efficacy. Here's the one I was looking for. This is from Zach Lamas, showing how many times bees swap from one host bee, how many times mites jump from one bee to the other. Some varroa switch 12 to 15 times in 15 days, so a bee a day. Slower ones only switch once in 15 days. So there is mite movement among the bees. So this is why we get these, you have to have that extended release is a slow death by 1,000 cuts. And when I modeled it, I'm not going to spend some time, but I have modeled it for both the vaporization and the dribble. And when I'm finding, from my data, it fits pretty much what we see in the field, except for one thing. It doesn't match the mite wash counts. And that's what's bugged me since 2018. You would expect that if you're killing mites all the time with extended release, that your mite wash, your count would go down immediately. And it doesn't. It goes up for a month. So even though the mite population of the hive is going down, the mite count on the adult bees goes up for a month before it drops. Again, totally counterintuitive. And I've thought about this a lot. I've talked to some other very smart people. I should say, I've talked to some very smart people. I don't want to pat myself on the back. And we all come up with exactly the same explanation. It's got to be changing the behavior of the mites. And they're not entering the brood. They're staying out on the phoretic stage. And that brings us back to those behavioral disruptors. And here's a really cool story. Back when tracheal mite invaded the United States. Okay, California, it killed 70% of the hives in California. It was brutal. 70% killed. We freaked out about tracheal mite. And the Tucson lab, USDA Tucson lab, did a bunch of research, and they found out the tracheal mites, when they come out of an adult bee, when they've grown up, they come out of the spiracles and they quest for a new host bee to infect. They can only, not infect, but to enter the spiracles. They can only enter the spiracles of a newly emerged worker, because after a few hours, their setae, the hairs around the spiracles harden up too much and the mites can't get in. So they need to be able to detect the specific odor of a newly emerged bee. Now, the way that they would treat infect bees or infest bees with tracheal mites is they would take young bees and put them into a tub with older bees that are infested, and let the mites transfer in that tub. Now, to keep the bees in the tub, they use standard technique used in insect labs. You take Vaseline on your finger and you wipe it around the inside of the top edge of the tub or the beaker, and that keeps insects from crawling out. So if you want to, back when I used to run an insectary for the university, and had raised thousands of cockroaches. And to keep cockroaches in a glass container, you just rub Vaseline around the top, and that keeps them in. Otherwise, they walk right up the glass. Anyway, the researchers at the Tucson lab, one of their experiments, none of the bees got infested. None of the young bees got infested. They go, what the heck? Why did it not work this time? It always works. And here's the important lesson. You always keep good lab notes when you're doing experiments. So they look back at their lab notes, and they go, wow, on that day, we ran out of Vaseline and we used Crisco instead. Could that have been it? So they experimented more and they found out, wow, if you put Crisco, expose those bees to Crisco, that messes up the smell for the mites, and the mites are unable to identify a newly emerged bee. It doesn't kill the mites, but because they can't identify a newly emerged bee to enter, the mites just die of desiccation or starvation without infesting a new bee. So we all started putting Crisco and sugar patties into our hive, completely non-toxic, but it kept the mites from reproducing. It was a behavioral disruptor. Wasn't that cool? And I'm wondering if that's what's happening with the oxalic acid and glycerin. When you treat glycerin with an acid, you form esters. So you make oxalic esters. Most all of your fruit smells and many of your flower smells are esters. They're very aromatic. And so we got up to this point. Let me hide my meeting controls here. Okay, so I put the bees, I sprayed half of them with oxalic acid and not the other half, put them in the incubator overnight to let it do its work on the bees. The next day, took the treated bees here, untreated bees here, and then went to a high mite hive, powder sugar dusted it, and collected 40 mites and dropped 40 mites into the middle to see which way they walked. If they all walk evenly to both sides, you wouldn't expect there's any odor difference. They almost all walked to one side. Very, very exciting. So I said, well, I'm going to build a new one here that is a narrower one and doesn't have any plastic. So I don't have any plastic odor disrupting. Got it all built, got ready to go. Went out to my 2 high mite hives last fall to collect live mites, and both hives were dead from the mites. So that's the problem. If you want to have a bunch of mites for doing live mite testing, you have to have colonies that are on the edge of dying from mites. So I'm sitting here now on the edge of my seat with my new behavioral assay device built, waiting to find a high mite hive. And if it shows that the mites are that oxalic acid and glycerin is changing their behavior, that's going to be a whole new, very, very exciting thing to look at. Okay, so wrap it up here. Here's my point. Right now, Amatraz is failing across the world, and people are freaking out looking at it. In our operation, we've run a commercial operation. For the last 21 years, we've never used a synthetic miticide other than in experiments. We've used only formic acid, thymol, and oxalic acid. My point is, we don't need breakthroughs or high-tech chemicals. We've already got the tools. We just need to learn how to use them. But the problem is, because we are kind of an orphan industry, the pesticide companies, the chemical companies, are not going to do all this experimentation and come up with different application methods of these products. So we are really screwed here. Now, New Zealand was brilliant. It said, wow, yeah, the beekeepers are important, but they're an orphan industry. There's not going to work. And the things they want to use, the organic acids and thymol, there's no risk to man or the environment. No, they don't contaminate the honey. There's no worry about it. So our Federal Insecticide and Rodenticide Act, FIFRA, which EPA follows, I proposed to them, why don't you just follow New Zealand's model? And New Zealand said, the exemption applies to any substance or compound prepared by a person for use on animals or plants that they own, or on any land, place, or water that they own or occupy. So any beekeeper could use it on their own. In a beekeeping context, the own use exemption is commonly used when a beekeeper prepares and applies preparations containing generic substances you buy off Amazon. You don't have to get a formulated product such as oxalic acid or formic acid or thymol to their own hives for control of varroa mites. So I propose this to EPA. How about just giving us an own use exemption? You guys get out of it entirely. You're not worried about us poisoning the honey or hurting anything. Just let us go ahead and do it, and let us experiment and tweak these methods. They were not into it at all. So, so very frustrating. These are last out of order. Okay, so in New Zealand, what they do is they sell these kits. So they cannot sell a formulated product, but they can sell you the oxalic acid. They can sell you the glycerin. They can sell you the chipboard strips and a bucket to make them in, and you just make them up at home. So that's would be the ideal. Now, 3 states somehow passed 2 EE exemptions to use oxalic acid at home. But as I pointed out, after you guys did that, EPA is not going to buy it because you've increased the dose. And the 2 EE exemption specifically says you cannot increase the dose. So even though, now, whether EPA will look at my data and realize, no, we did not increase the dose with extended release. You're down to 3 micrograms per B. That's not an increased dose. It's just an extended release dose. We'll see. We're arguing with them right now to see. And Pat, we want your help. My point now is we've got to put a flame under our industry leaders and our elected representatives to legislate an own use exemption for us. We already have the model. We already have New Zealand doing it. EPA or our legislators can look and ask New Zealand, are you getting a bunch of beekeepers being poisoned or anything? And they're going to say, no, that's ridiculous. It works, but we need people to take action. I've been asking the AHPA, American Honey Producers, and ABF for years. Let's take some action, get your lobbyists on here, and it's fallen on deaf ears. I have another friend right now who has now just been given the public relations position for ABF, and he's starting to put a fire. He can use all the support. Charlie Linder is my friend, and he could use all the support. Start pressuring your national organization. If you're a member, saying, I want to see action. Start pressuring your state legislator. All we need to find is one congressperson who says, oh, we can help the beekeepers very easy. Just pass a law, an own use exemption, and circumvent EPA entirely. And we'd be fine. And we could experiment with this oxalic acid and formic and thymol on our own and come up with ways to do it, not dependent upon a chemical company to do it and go through a very expensive process with EPA, which they are not going to do. It's not going to happen. So that's what I hope you can help us with. And that's the end of my presentation. What do we do for time?
Thank you.
Okay, hour and a half. Okay.
One quick question about food grade glycerin. What's a good way to get a bulk amount?
There are companies that sell up to a 55-gallon drum. Duba Diesel sells it. Hang on, I'm going to stop my share here. Okay, so Duba Diesel, I know, sells it. You can buy it by the gallon on Amazon. I prefer to get soy glycerin rather than palm glycerin. Palm glycerin means they got to cut down the Indonesian rainforest and drive species to extinction, the orangutans and others. But the soy glycerin is produced here in the US, so we tend to buy soy glycerin.
Yes, New York State does have an approved. It's in the chat. The link for the chat in the chat for the
yeah, for the extended use, yes. But EPA is going to probably reject that soon.
Yeah, so if anyone wants to contact Senators Gillibrand or Schumer, go ahead and
yeah. Are your Congress people?
Do we really need to kill the mite, or is it interfering with successful reproduction enough? Did I read that the foot pad system is responsible for larva selection for the foundress mite?
Okay, the last set. I didn't quite understand the question, but I tell you right now, that's the whole thing I'm talking about. If it's behavioral disruption, then you're not necessarily killing them. And with the, there is clearly acute toxicity, but this is like with my selective breeding program. You don't ever have to kill a mite. All you got to do is just to control varroa, you just slow down its reproductive success. So if we're getting behavioral disruption and they're staying phoretic until they die rather than entering a brood cell, they can die of old age and you've eliminated the mite. That may be why it takes 70 days, because you're not directly killing them, you're just keeping them from reproducing.
In New York State, when would be the best time to treat using oxalic extended pads? Early June, late in the summer, early fall, or late fall?
Okay. As I hesitate to give any recommendations, but because I don't have data, field data support it. I can tell you that in our experiments where we have put it on at the beginning of your honey flow, when you're putting honey supers on, and just leave it in there for 2 months, that works well. So we've done a lot of it where we put it in hives in July, and by the time you take your honey supers off in late summer, you got no mites in the hive. It works really well. I have done one wintertime, very small trial. It did not seem to hurt the bees, but did not exhibit any much efficacy against the mites either. So in a varroa management strategy, that June, July through September may be the best place to use the extended release.
How about treating twice during the season?
Well, then again, you're starting to get down to one mode of action. So now you have a very long selective breeding for resistant mites. You've just taken it from 60 days to 120 days, almost half the year. So I recommend against counting on one miticide for a long time. So we use, if you go to my beginning beekeeping web page, look down to the bottom, it has selected suggested treatments. Hang on, let me.
Any effects on oxalic on drones for mating?
I don't know. I haven't seen any data on that. Could not tell you. Give it up.
Okay. If the goal is to have all the bees dosed with oxalic, would it be feasible to place the pads at the entrances of the hive and circumvent the need to open the hive and place the pads on the frames?
Yes, we have tried that, and actually, okay, if we go, let me go. I can show you the. I didn't point that out, that we did that in that trial, and showed that we put them across the entrance and then one on top just under the lid to see what would happen. And if I can reopen, okay. This one right here, this blue line right here. Okay, that's at the entrance and at the and one under the cover right here. And actually, see, it's holding it pretty well. Now, I don't have data from my control, but it is keeping the residue level up there. So I have done it a little bit and did get some mite control, but I've only done it on a few hives, not enough to get considered to be hard data.
Okay, if esters are attracting the mites, are other esters being investigated?
I never said they were attracting the mite.
Okay.
And no, hey guys, you're seeing one beekeeper out of California, and this is research that we should be having, 50 people doing, or the chemical pesticide companies that, I'm one small guy, and you're asking all good questions that I am asking myself too, but I only have 24 hours in the day, and I use them all.
Is soy glycerin the same as vegetable glycerin?
It is a vegetable glycerin, but palm glycerin is also a vegetable glycerin. And a lot of times you can't tell. So I shop to look for the soy.
One person said, I accidentally made maximizer pads with 40 grams of oxalic last year instead of 50. Excellent mite control. Do you plan any trials to evaluate doses lower than 50?
Yes, I do. Thank you.
If using 3 medium brood boxes instead of 2 deeps, can you provide suggestion on where to place the pads?
No, but after you let me know after you experiment. I'm interested in your results.
When you hang the strips over the frames instead of laying them down on top of the frames, do you encounter any problem with them damaging open brood?
The bees, I haven't looked to see the immediate effect, but they tend, either that brood is removed or after it emerges, it comes out, and it depends on how close it is to the brood. So it's not like a major thing, and the strips don't cover that much area anyway.
Is there a downside to using the Crisco sugar patties?
Not that I know of, but that's for tracheal mite, not for
Right.
varroa mite. Although I don't know if anybody's ever tested it for varroa mite. Wow, great idea.
One person asked, how can we best network with you to help with your experimentation and data collection?
The problem is most beekeepers don't have enough hives to do it, to do even the smallest test possible of testing one thing. You need at least 12 hives per group to get any significant statistical significance. So that means 24 hives minimum to do even the smallest test. So very few beekeepers have that. So larger scale beekeepers, and I'm way interested. I'm trying to delegate out as much research as possible. I got a to-do list that we got through half of our to-dos last year. I'm getting local beekeepers and just saying, here, you can use my hives. I'm going to delegate this protocol for you to follow up. We'll help you out, but spread it out to people. So I'm happy to work with any group, okay, that does have enough hives to do meaningful research.
Okay, just a few more questions. Have you tried sponges on singles directly under a queen excluder?
Yes, but hung over the strips, not laid flat. Hung over the frames, I mean, but not laid flat.
And how long can you store sponges for future use?
The cellulose starts to degrade after a month or two a bit. They get a little bit weaker. So it depends upon the particular matrix.
Have you seen any colonies propolize the sponges?
Very few. With the shop towels, yes. But with the sponges, very, very few. If they stay moist on the top, they tend not to be propolized.
One person wants to know, what is the New Zealand law number for the own use exemption so that we can pass that along to the powers that be?
Well, I got a link to it on my website. I could, if you email me, Pat, to remind me, I'll send you a copy of it.
Okay, I think that's good for now. Scratch the surface on this. Thank you very much.
You ready to hand out the test? a lot of information.
Yes.
But this is so exciting having this insight. See, now at this point, now I don't have to necessarily run a big trial with 100 hives. I can just look at the residues there and just take a look, and that's very easy to titrate that out and do a lot of preliminary research just based on the residues.
All right, well, thank you again, and good night.
All right. Good night, everybody. Happy beekeeping.